A storm with 6 perfect sides has raged for decades, and no one can agree why it exists. Voyager first spotted Saturn's hexagon at the North Pole, 29,000 kilometers wide, unmoving. So how does such a shape even form? On Earth, storms curve and wrap themselves into spirals. But on Saturn, there's a storm that draws a ruler straight edge, like geometry written into clouds. Storms shouldn't make polygons. Why doesn't this boundary just fade away? Voyager imaged the hexagon in the early 1980s, just below 78 degrees north. Saturn spun underneath, but the hexagon kept its flawless lines. Somehow, a 6-sided pattern survived every rotation. Why didn't spinning scatter the edges? Cassini watched for years as the pole emerged from night. The hexagon came back, same dimensions, but its color faded from pale blue to golden honey. This hexagon isn't a rigid wall. Something in Saturn's wind redraws it, season after season. Some imagined a hidden mountain range slicing waves in the clouds. But Saturn doesn't have solid surfaces, just atmosphere all the way down. No wall could anchor this hexagon. So if it's not carved by ground, what's holding those sharp corners? Maybe gravity or ice plates could lock in the shape? Forget it. Those can't steer an atmospheric jet moving 100 meters per second. The real driver must fit the speeds actually measured around the hexagon's path. Something else is at work. Spin a narrow tank and something weird happens. The fluid core can snap into polygons. Oxford lab experiments show, trigger a fast enough shear and you get not just circles, but triangles, squares, even 6-sided jets. What if Saturn's winds do the same dance? Leading models point to a standing Rossby wave, trapped in the eastward jet by Saturn's unique polar conditions. The jet's twist locks into 6 repeating lobes, a frozen hexagon on the clouds. But why does it stay locked into exactly 6, not 5 or 7 lobes? Cassini's infrared spectrometer finds the hexagon goes deep, hundreds of kilometers, not just a surface trick. At the core, there's a separate polar cyclone, spinning solo inside the hexagon's boundary. We're dealing with a structure that wraps the whole pole. With each Saturnian season, sunlight changes the chemistry. UV builds a golden haze, and the hexagon's color intensifies or fades. But here's the kicker. The shape stays constant. The lines themselves are drawn by waves, not by sunlight or photochemical paint. And the hexagon's rotation doesn't perfectly match Saturn's internal clock. Its drift rate runs just slightly off direction from what the core dictates, hinting this shape isn't rooted deep inside. Whatever holds it together, it's not Saturn's solid heart. Simulations let scientists tune jet speed and shear. Turns out the number of polygon sides is sensitive. A little too fast, you get 7. Too slow, maybe 5. Saturn's polar jet sits in a narrow sweet spot where 6-sided symmetry emerges and holds. All those straight edges aren't walls. They're where a meandering planetary wave snaps into a stationary dance. Saturn's boss polar jet lets a Rossby wave freeze, locking 6 crests in place. The hexagon is pure motion, not a solid thing at all. Rossby waves come from a planet's need to balance spin and vorticity. On fast rotators like Saturn, these waves reshape jet streams, and at a precise speed, the wave and the jet cancel, locking the pattern into place. It's fluid math, held still by motion. Unlocking Saturn's hexagon decodes more than one mystery. Lab tanks also spawn polygons. Jupiter's poles form wild polygonal cyclones too. Break the hexagon code and you're holding a key to forecasting weather here, across the solar system, even on alien worlds. We can finally sketch how the hexagon stands still. But just how deep this wave runs, what powers it for decades, and how Saturn's seasons stir the mix, those are still unsolved. The best mysteries never reveal everything at once. As technology leaps forward, Earth telescopes and Cassini data dig deeper. Each passing Saturnian season peels back one more layer. New missions may soon reveal exactly how far down the hexagon goes, and whether it ever shifts, splits, or snaps away. Saturn's hexagon is no wall, it's a standing wave. Fluid physics etches geometry into planetary skies. Understand it and you see echoes shaping weather everywhere, from gas giants to Earth's own storms. You now understand something most science textbooks leave out. Hit subscribe. The next discovery is already waiting.